as far as answering some of these tougher questions down here. So let's go down here. All right, and let's see what we got. All right, number 64. All right, it says an artist creates metal sculptures in the shape of irregular octagons. The side length of the larger sculpture is 7 inches, and the area of the base of the smaller is 19.28 square inches. What is the side length of the smaller sculpture? Yeah, so this one's kind of tricky because you have to actually draw the octagon. All right, let me show you what I mean by that. All right, so the side length of the larger sculpture is 7 inches. So here's what I want you to do. All right, we're going to draw this here and this here, and that is the octagon. Does everybody agree? So if the side length is 7, remember if I draw this in here and here, this one's, again, very important, guys. So when I draw, or when I want to know the area, it would be 8 times 1/2 base times height. Does everybody agree with that? All right. Now, we already know the base is 7, so area equals 8 times 1/2 times 7. Now, here's the problem. When we draw this in here, you have to remember this becomes 3.5. The angles of the central angle of an octagon is 45 degrees. So this angle here would be 22.5. And I'm interested in the height. So what trig function am I going to use for that? Tangent. Come on, guys. Make sure you're listening. That is the tangent. All right. So here we go. So I have the tangent of 22.5 is equal to, thank you, 3.5 over h. So now h is equal to, beautiful. And then someone tell me that's approximately what? Bless you. 8.45. All right. So that right there is the height. So this come up here would be 8.45. So now the area of the large or the large octagon. Somebody tell me what the area of the large octagon would be. 236.6. About 236.6. Is that good? Inches squared. All right, and that again is the large. I want to make sure we got that. That's the large. What? 3.5 divided by tangent of 22.5. Thank you. Somebody else double check me.
No, I got 8.1.
That's okay. That's what I'm saying. It's very important. That's what I'm saying. Everybody's got to do it on their calculator. I promise you, if all you're doing is writing down my answers, when you take the test tomorrow, you're not going to know what's going on. You get it yet? Mode. Go to your mode. Make sure you're in the right mode. Mode, you should be in degrees. Is that better now? Ask him. Well, here, bring it up here. Let me show you. You can reset it. All right.
It like died the other day, and it restarted.
Mode, so you're in radians. Okay. Show me. Radians. We're in radians. Okay, so now I have the large area, and then it says the area of the base of the smaller is 19.28. So 19.28. Divide those out for me. Come on now, please pay attention. I think these are easy, but for whatever reason, It's difficult. I don't know why. Divide that out. What do we get?
12.27.
So the area is 12 point whatever times greater. You agree? So now I'm interested in the side. So what do I have to do to that? Take the square root of that number. So everybody type in square root of the answer. And now that's telling you that the side is 3.5 times larger, correct? It's not what the side is. It's 3.5 times larger, correct? So we have the side of the what? Larger. We want the side of the smaller. Divide that by about 3.5. Is that what it was?
Yeah, 2.
Yeah. So 2-ish. All right? 2 inches. Roughly. Now remember what I'm saying, guys. You can't do that, right, unless you're going through the motions with me. Honestly, and I think it's easy. But a lot of kids stumble on these particular problems, and I just, the relationship is simple to see if you're doing it.
Can we go through it one more time?
What?
Like,
I'm not doing the whole thing over, no.
no, after the divided by 19.
Okay, so what did you get?
I got 12.2.
Okay, so now hear me. That's the ratio of the areas.
Okay.
So if I want to find the ratio of the sides, you take the square root of that answer.
Okay.
You agree with that? So do the ratio, square root of that answer.
I got 3.5.
So the side is 3.5 times larger than the small side. Do you agree? So if the large is 7, 7 divided by that answer is roughly 2-ish.
Oh.
Right? I'm telling you, it's really simple if you're following me. All right. Now, what made this particularly hard was we had to find the area of the octagon first, which is on the test. All right. Now it says the artist is going back to the sculpture in a circular box to take them to an art show. Will the large sculpture fit in a circular box with a 15-inch diameter? All right. Well, how do I know that?
Because twice the length would be 16 or 17.
How do we? But that's not the largest part of it, is it? No. What you're not understanding is this, guys. Please look up so I can show you. I think this is a very good question. Why not?
So I just took the height and I multiplied it by 2, and it wouldn't fit in.
Oh yeah, that's a quick way. Even though again, that's not the actual largest part of the octagon, is it?
It's the
Well,
hypotenuse of that triangle.
Yeah, times 2. Right. You listen up now. What I'm saying, because again, guys, I just think these are really nice questions. All right. If I were to finish drawing the octagon, I'm going to try to draw something up here, even though it's not complete. So everybody agree that's the opposite side of the octagon, right? So from here to here would have to fit, correct? But we already know that height is what? 8.45. Does everybody agree? So as we know, it's definitely not going to fit. You agree? However, what if that was like 7? It might fit now, correct? But remember, that's not the largest distance. The largest distance is from corner to corner. You agree with that? All right, so it's still not going to fit. All right, again, I hope some of you guys, and if you're not seeing it, I want to help. If you're not paying attention, I don't really care. All right, if you're trying to think about it, I want to help you if you can't see it. All right?
Why can't you just do the areas?
Because, believe it or not, someone asked me this question a while ago. Can the perimeter be bigger than the area?
Yes.
Yeah, think about just a square with side 1. You with me? It has nothing to do with how this, right? It has everything to do with not the area, but has to do with the length, correct? Because you can get there's an interesting puzzle about walking something through that door, right? The largest object that can go through that door would be the what?
A little smaller.
No. Come on, man.
The diagonal.
It would be the diagonal, right? You have to go from here to here, right? Because you can turn it on its side. This is not the largest, right? That's not the largest is the what? The diagonal. Right? So let's just say that's 7 feet tall. I can fit something greater than 7 feet through that door. Everybody understand what I'm saying, right? Okay. You don't need anything about the perimeter, is what I was saying. Some people just think that the area is greater than the perimeter. They're different measurements, right? So because something is 4 square inches and something is 4 inches, you can't say what's bigger, right? It makes no sense. You're comparing different dimensions. All right? Hopefully you understood what I said. All right. So we're good. All right, let's look at 63. It says a circular pool is surrounded by a circular sidewalk. The circular sidewalk is 3 feet wide. The diameter of the sidewalk and the pool is 26 feet. What's the diameter of the pool? That's easy, right? 20 feet. Does everybody agree? Right? Come on now. And again, if you're making a mistake if you're not putting up here what? That's 3, and that's 3. And then from here to here is what? 26. That's what you should be doing. And then obviously the diameter is now what? 20 feet by drawing it out. What's the area of the sidewalk? Well, the area of the sidewalk is going to be, tell me how to do it. Good.
I just added area of the sidewalk and the pool. Which was the question asked me, so I took the diameter of 26 and made the radius 13 and then plugged it into the circle.
But that's not just the area of, what is the area of the sidewalk?
And the pool.
Okay, so I'm not, that's kind of, does everybody understand what I'm saying there? To me, personally, I would have said, what's the area of the sidewalk? And then figure out what the area of the pool is. Right, but you could read it as, what's the whole area? Right, so I don't really care. So listen to me, it's not going to be that. Now, so if I wanted this, the radius would be how much then? Right, the radius would be 13. And the radius of the pool would be what? 10. So if I wanted to know just what the area of the sidewalk was, it would be pi r squared minus pi r squared, right? So it would be pi times 13 squared minus pi times 10 squared, which I think is, what, 69 pi, I think? Right? Because 13 squared is 169, and then 10 squared is 100 pi. Does everybody agree with that? Right? So then this area over here, all right, perfect. Everybody okay with that? I don't care what the question is, right? That's just a way to figure out what the area of the pool is. We can figure out what the area of the sidewalk is. You can figure out what the area of the pool and the sidewalk is. All right? It doesn't matter. All right? The question is a little unclear in my opinion. All right, let's keep going. Okay, is this one easy? 62. All right. A running track has an inner and outer edge. Both the inner and outer edge consist of 2 semicircles joined by 2 straight line segments. The straight line segments are 100 yards long. The radius of the inner edge is 25, and the outer edge is 32. What is the area of the track? So now we just want the area of the what? Just the area of the shaded region. Does everybody agree with this? Right? So the question is, come on now. I don't think it's necessary to do all this. All right, but this is how you should be thinking. Right? This is easy to figure out, this area right here, correct? And then we'd multiply that by what? 2, because it's the same as this down here. All right? Now, what's the outer radius?
32.
32, and the inner radius is? So that means this distance right here is 7. Does everybody agree with that? The outer radius from here to here, somebody just told me was 32, right? The inner radius, someone just told me was 25. Does everybody agree with that? So now does everybody see why I got 7? Right? So then this area right here would be how much? How much? And then this would be So we're almost there. What do we got so far? 1,400 square yards so far. Everybody agree? Now, does everybody see the other one is circle, right? Large minus small. All right, so we have area equals pi, parentheses, capital R squared minus lowercase r squared. If you can't see that, let me know. Do you agree with me? Because it's just pi r squared minus pi r squared, right? But I factored out a what? Factored out a pi. So to me, it was easier just to square the r's and subtract them and then put the pi at the end. Everybody agree? So what's the radius of the large one again? So 32 squared minus what's the radius of the smaller one? So somebody do 32 squared minus 25 squared. Plus 399 pi. That's the answer. Now hopefully you remember what I just said earlier. You're not going to be able to do it if you're just following along. You haven't thought about it. What? Absolutely.
I was talking about like if we keep it in the pi format or
I don't, yeah, just, I like pi, you know that. But if you do it as a decimal, I always figure it out because some of you don't listen. All right. All right. It says down here, round your answer to the nearest hundred. All right. But if you leave it pi, what?
I had to look at something. Would you mind going over how you got the 399?
Well, I didn't do that. Somebody else did it for me. The large radius, what did we say the large radius was? So it's 32 squared minus 25 squared. So do that. Tell me what that is. Hopefully somebody else did that. That's where I got that from. You see it now, right?
Yeah.
All right, so I'm pretty happy with that. All right, let's go on down here. 61. So what's the formula for area of a trapezoid? Now how many of them are there? 2. Are they the same? No. So it's kind of boring. 1/2 B1 plus B2 times the height. So what's the area of the top trapezoid? Someone. How much? 375. And then what's the area of the bottom one, please? 300. So the total area is 675 centimeters square. Well, yeah, don't be confused by this line right here. Do you agree? All right. That's just showing you that that's the what? The height. Do you agree with me? We don't want to break it up. Those are the 2 trapezoids they're referring to. Okay? Here we go.
30 represents that whole neck across, not just like 2 that.
Yeah, I think 30 represents from here to here. Because I don't think you could figure the other part out. Does that make sense? Sometimes that's how I figure it out, because they're not clear. All right. What they should have done was they should have dotted that line right there. Then it would have been better. All right. Just like they did here. All right. So a rectangular billboard casts a shadow on the ground in the shape of a parallelogram. All right. So what's the formula for area of a parallelogram? Area equals base times height. The base is what? Uh-oh. That's right. But what's the height? You have to figure that out, right? Now, remember, we're practicing right now. All right? I want everybody to be able to look at that, and I want everybody to be able to say, that is just 15 radical 3. Everybody agree? It is a 30, 60, 90. That is true, but we don't know that. That was good if you know that, because it is half. As soon as you're half, right? But now listen to me. This is also, remember, 15 times 2. This is 15 times 1. So that's just simply 15 times the square root of 4 minus 1, or 3. Right? Come on, guys. Make sure you're understanding me about that number. If you're not sure about how I got 15 radical 3, let me know. Let me say it one more time. You ready? Do you understand that this, it's a right triangle, right? So this is 15 times 1, this is 15 times 2. So this has to be 15 times something. Right? And so now we're going to do the Pythagorean theorem with 1 and 2. But 2 is the hypotenuse, so it's 4 minus 1. Agreed? Because I don't feel like doing 15 squared, 30 squared. Yeah, some of you guys keep listening and it'll sink in. All right, you may not see it the first or second, or this is, the 10th time we've done that, but that's okay. All right, now it's 15 times what? 15 radical 3, which is 225 radical 3 square feet. All right, I wish you would leave it like that, but some of you are stubborn. I agree. All right, here we go. Let's have some more fun. All right, 58. This is an ACT question. What is the area of the trapezoid? Simple. Everybody agree? Right, now they're trying to confuse you by putting this 5 here, right? That's not the height. Right, the perpendicular distance is the height. So is everybody okay with that being F? All right, let's keep going. 50, wow, what happened? All right, so 40, here we go. I don't know what happened to those. All right, 40 is another ACT question. The angle opposite the 80-foot side measure. Thank you. I was wondering about that. Okay, so yeah, so now we have to start back up here. All right, so these 3 questions go to these right here. All right. So a bag of fertilizer costs $7.99 and will cover approximately 500 square feet. Which of the following is close to the cost in dollars of fertilizing the flower bed? All right, so the area here is how much? Yeah, 6,000 square feet, right? And now it says, how many bags am I going to need? Right, I'm going to need 12 bags, correct? Yep, and then multiply that by $7.99. And it's roughly what? Guys, is everybody happy with that? All right, that's a really good question again. All right, lots of things you have to keep track of. Anybody have any issues with that?
How did you get 12 bags?
Well, because it's 500 square feet per bag.
Oh.
So 6,000 divided by 500. 12 bags, right? And each bag costs $8. Yes, 8, 15, 17. Yeah. Okay, 39. So to determine how much fencing to buy, right, we need the perimeter. So again, someone was just saying 8, 15, what? 17. So this is 170. Does everybody agree? So that would be a total of what? 400. That's not bad. Now it says the angle opposite the 80-foot side. So that would be this angle is what they're talking about, right? What's its dimension? What does it say? 28.1 degrees. We could have figured that out anyway. Right? Now it says Hansen is considering changing the shape of their flower bed. It will still be a right triangle with the 150-foot side as one leg, but they will extend the 80-foot side until the angle opposite that side is about 40 degrees. By how many feet would they need to extend the 80-foot side? Okay, so this is what we got here. This is a pretty good question. Right, so we're extending this here. Does everybody agree? Is that what it's saying? We're extending the 80-foot side. Now, come on, these are the good questions right here. All right? This is where you can determine how good you're thinking. But I'm extending the 80-foot side. Does everybody agree with that? And I'm trying to make this angle now a what? I'm trying to make it a 40-degree angle, correct? Now, honestly, I don't think I taught you guys the law of sines. I don't think you can really do this one. Well, if that's, no, I think we can do this. If this is 28.1 and it's 40 degrees, then the extra angle right here would be what? 11.9, right? Okay, yeah, we can do this. This is 11.9 degrees, correct? And now they wanted to know what this extension is right here, correct? And we have 150. I forgot we had 150. So what do I have to do for that? Tangent of 11.9 is equal to x over 150. Agreed? So now somebody do 150 times tangent of 11.9.
31.66.
Is that an answer?
Yes.
No, it's not.
It wants it to be a right triangle. It was kind of
Yeah. So I
So I was confused. You guys said to the right.
What did I do wrong?
You made it so that it's supposed to be a right triangle still.
Extend the 81 to the right.
Yeah. So that 100
Hold on a minute. Now I can't read that right. The angle opposite the 80 can't say, are considering changing the shape of the color. It will still be a right triangle
Yeah.
with a 150-foot side as one leg. Okay. But they will extend the 80-foot side.
So the 80-foot side would be extending to the right rather
Yeah.
than the left.
Oh, yes. Thank you. Right, yep. I totally did it backwards. Thank you, guys. That was good. All right. So let's move that out of the way. Over here, get that out of the way. So this is what we're doing here. Now, this right here, come on, that is now 40 degrees, correct? So now, if we do the tangent of 40 is equal to x over 150. Does everybody agree with that? Now remember, x is going to be this, and then I'm just going to subtract 80, right? So now do 150 times tangent of 40,
125.
and then subtract 80. Is that an answer? Yay, so that's good. Very good, guys. That's good. Right, so even, listen, that's a good demonstration right there of how I just did it wrong. It didn't match the answer, so they're not going to be wrong. So then we just readjust, read it again, and see if we can reassess what the problem was. All right? Very, very good question. Very, very difficult. All right? Here we go. Let's move on. We did all those, it looks like. We did here. All right, yeah. Let's do this, number 48. I need everybody to be able to convert that into center radius format. I don't really care about graphing as much as I care about you can convert that into center radius. So again, let's review. X squared plus 4x, leave a space, plus y squared minus 12y equals what? 9. Now remember, to complete the square, you do half and square the middle term, so that would be what? Plus 4. And then this would be plus 36. So plus 4 plus 36. Right? So then that becomes what? Plus
2 squared plus
good, you're right. Equals how much? I think it's 49, right?
Yeah.
49. Okay, that's on the test for sure, guys. You have to convert from standard to center form. All right, so now the center you should be able to tell me now is what? And the radius is beautiful, guys. You have to know how to do that. It's a big part of the SAT, believe it. All right, here we go. Let's find something else. Do I need to practice that, or you guys got it? You want me to do 46? All right.
We just did that type of problem.
Yeah. All right, so let's just make sure. X squared plus 6x, leave a space, plus y squared minus 6y, leave a space, equals -9. So when you half and square, it's going to be what? Plus 9, and then, yep, plus 9 and plus 9. So then it factors into
X plus 3 squared plus y minus 3 squared equals 9.
beautiful. So the center is, and the radius is, wow. Anybody have any questions with that? Anybody? All right. 45 is kind of easy, right? It's just x squared plus y squared equals 4. Your center is what? 0, 0, and your radius is 2. Be careful. Radius is 2. Yes, you take the square root. Because remember, that's r squared. R squared. All right, here we go. Now write in the equation. So over here, x squared plus y squared, the radius is 9, so 81. The center is -711, so it's going to be x. Perfect. All right, now the next one's kind of important. So the center is -1/8, so that becomes that's what you have right there. So double check that, make sure you're good with that so far, right? You with me back there? Okay. Now I need r, right? So now I just plug what? 9 and 3 in for x and y. So what's 9 plus 1? Squared. 100. Plug y in, you get. Right, so r squared equals what? So now you just replace that r squared with what? I don't care what the radius is. Not asking me for the radius. But the radius would be the square root of 125, which everybody knows is 5 radical 5. If they ask you, correct? All right. So same problem on 44.
X plus 3 squared.
Good job. I'm listening.
Y plus 3 squared. And then we do equals y squared.
All right. When you plug it in, what do we get?
1 plus
1 plus what? 36. Good job. So r squared equals what? 37. Come on now. I keep trying to tell some of you guys. You got to be doing the work. Can't be watching me. Everybody good with that? That's a good review right there of circles. All right, good review of circles. Very, very important part. All right. If one diagonal of rhombus is 15 and its area is 157.5, so what's the formula for area of a rhombus?
1/2
D1 times D2.
Exactly. So 157.5 is equal to 1/2 times 15 times the other diagonal, or x. It's easy if you know the what? Formulas. If you don't know the formulas, it's impossible. All right. So what do we got here? Diagonal is 21. All right. Now 39 is a really important one, so let's go ahead and knock this out. Or I have a hexagon subtracted from the what? Circle, right? So I would want everybody to just say this is A equals pi r squared minus 6 times 1/2 BH. Honestly, I just feel like you should be able to do that. Everybody agree? What's the radius? So here we go. Area equals pi times 8 squared minus 6 times 1/2. What's the base? 8. What's the height? Come on.
4 radical 3.
Yay, good job. 4 radical 3. Look at that now. It's an equilateral triangle. The hexagon makes an equilateral triangle. So the base is 8. The height is half times radical 3. Everybody good on that? So again, I would ask you to probably write the answer as 64 pi minus, what is that, 96? That should be a plus, square root 3. But double check me on that. Is that right? 24, 96, yeah.
Yeah, that's right.
So 64 pi, make sure that's correct. Plus 96 radical 3. And of course it would be inches squared. Everybody can do that, right? That wasn't bad. All right, now another good review problem right here. All right. What's the, come on, Alessandra, what? You good or not? Oh, I changed it plus for whatever reason.
Oh, okay.
My fault, guys. Yeah, thank you. It's not. It's subtraction. I don't know why I put plus. Thank you, Alessandra. Minus. Everybody good now on that? Yes, sir. Yeah. So for
How do you know which, when you're doing a proportion like that, because for example, that was 14 over 11, how do you know which one's on top?
doesn't matter. But I personally always do the large divided by the small. Always. And if you do that, I don't really care either, because to me it just makes it easier. Because in my mind, I can say, okay, that number is going to always be greater than 1. Do you agree with me? So if I'm going to something bigger, I multiply. If I'm going to something smaller, I what? It's so much easier, in my opinion, thinking like that. All right, I always do the large divided by the small. So in my calculator, I'd like you to do just 28 divided by 22. Then we're going to the area. So I don't care what the answer is on the calculator. I care that you know that you got to square that. And when you square that, what decimal comes out?
1.6.
Blah, 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 right?
Yeah.
1 point, whatever that is. All right. Now, are we going bigger or smaller? Smaller, so I'd have to take 140 divided by that answer.
86.4.
And then you can hit math, enter, enter if you want. And what is it? Oh, that's right. You don't get a fraction because it wasn't a perfect square. Thank you. It was considered an irrational. Listen to what I'm saying, because most kids don't understand. They get on their calculator and say, I hit math, enter, enter, and it didn't give me a fraction. What's wrong with my calculator? It's that answer is a what type of number? Irrational. So the calculator can't turn it to a rational if it's irrational. Is everybody hearing me on that? All right. So again, someone tell me the approximate area of the smaller one is about 86.4 centimeters squared. Come on now. Tell me again. Go. Nicholas, I want to help you. What?
I was making sure that, so when you try to find the area for these like similar things,
Yep.
you square it, but then when you try to find the side,
You take the square root. If you have the ratio of the areas, right? So to get to the ratio of the areas to the side, you take the square root. Sides to area, you square. In other words, if you remember it like this, it's helpful. A to B is equal to A squared to B squared when you're talking about area. So if I'm at this and I want to get to this, I take the square root. If I'm here to here, I square. Then I can tell what the area is. All right, okay, so just for practice here, guys, let's go. Everybody should just be a one-step calculator problem. 19.5 divided by 15. Then you do what? Square. And then multiply it by 75.
I got
126 point, roughly. Good. Or is that exactly? Oh, yeah. Because probably 19.5, 49, 39. Yeah, 88%. All right, is everybody okay with that? 126.75, and don't forget the units on your test tomorrow. All right, let's go. Let's have some more fun. The area of a circle is that. What's the diameter? So everybody's just typing this in on the calculator. This is boring. 254.5 divided by what? Pi. Then you do what? Square root. And then you multiply by 2. How much? About 17.7
just got
or exactly 18.
18.001.
Because you get 81.01 and then if you split it
So
out-
did you guys do 3.14 or did you guys use pi?
I use pi.
All right, so let's try to double check because it's a little bit off. And I wouldn't care on the test, of course. But just do 254.5 divided by pi. What does that say? So if it says 81 point something, right, then you automatically know they just want what? 9, probably.
It's like
Right.
0.01. So.
Yep, so I'm good with that. So 18 feet. 18 feet. Let's go. The area of rhombus, one diagonal is 3 times the other. So what's the formula? 1/2. Right, so it would be 1/2 x times what? 3x is equal to 337.5. So multiply by 2, divide by 3, square root. Do I agree with that? So somebody tell me what x squared equals in this case. How much? 225. So x is equal to 15. Now don't stop there. Right? You got to make sure you answer the question. What are the lengths of the diagonals? 15 and what? 45. Okay, I'm pretty happy with that. All right, the height of a triangle is 4 meters more than its base. Okay, for whatever reason, some kids mess this up. Area equals 1/2 base times height. The area is what? 160, right? So 160 is equal to 1/2 times, the height is 4 more than the base, so b, and then b plus 4. Does everybody agree with that? So then 320 is equal to b squared plus 4b, right? So b squared plus 4b minus 320 is equal to 0. Does that factor? 16 and 20, right?
Yes, sir.
Is that right? 16 and 20, guys. So then that would be b plus 20 and b minus 16, correct? This would be an extraneous solution, so b is equal to 16. So one is, base is 16 and base is what? Yeah, height is 20, thank you. All right, remember reviewing your math there on that. All right, let's have some more fun. All right, these are just finding the area, so that's just the area of a what? Triangle and a semicircle. So again, A equals 1/2. What's the base of the triangle? What's the height? And then plus 1/2 pi. What's the radius? 0.8 squared. Right? So what's that? 1.28 plus 0.32 pi. Is that right? Keep it like that. Makes you look smart. What? Come on. 0.8 is the radius of the semicircle. Point what? And then take half of it. Right, take half because it's half the circle. Agreed?
Yeah.
Right? So on 32, we're just doing the area is equal to, right, 9 times 15 plus 1/2. What's the base of the triangle? 9. What's the height of the triangle? Beautiful. So somebody tell me what that is. What is it? 189 square centimeters. All right, 31. Okay, it's a good review question. All right, so the area of the shaded region is pi r squared times n over 360. Does everybody agree? What is n in this case? 255. Thank you very much. So A equals pi. What's the radius? 16 squared times 255 out of 360. Very good. Does everybody agree how simple that is, right? Just a fractional part of the area of the circle. right? The easy formula. Anybody have any questions with that? Come on, speak up. So remember, from here to here is 105, right? Tells you that's 105, right? So then that's the rest of 360. 360 minus 105. All right, guys. Pretty good, pretty good, pretty good. Let me see. I think the rest of the solutions are actually at the bottom of the page. All right, let me see if I can find them. Yeah. I'll see what I can do.